Hello everyone, welcome back to my channel. So I'll be solving another LeetCode problem called implement trie, which is a prefix tree. So this is a unique type of data structure. If you haven't already, then it's a very useful data structure which gets used in a lot of interview problems. So you can think of trie as essentially a dictionary, right? So if you want to look this particular word in a dictionary, what you do is you actually go to I. So you traverse from starting of the dictionary, which starts with A. So you go through all the alphabet from A, B, C, D, E, F till I. And once you reach the first instance of I, then you look for the next word. So the next word is going to be N, right? So after I, it's going to be all the words from IA, IB, IC, ID until IN. So you go one by one at every character. You start traversing from A till that particular character. So essentially that's the concept of trie. So what we do is we create a node of like it's essentially tree, but the top level node is the first character. The second level node is whatever the second character is. So this, for example, this one. So if you want to create a trie of insert, the first node will have I, and then there will be different nodes. So there can be maximum 26 nodes, right? So if you think about it, we have 26 characters. So there is one top node, or there can be 26 top nodes, and all the 26 nodes will essentially denote the first character in a word. So in this case it's going to be I. So I, and then there will be another node attached to it which will have N in it. Then N will have another second level node S in it, and then S will be connected to E, and then E will be connected to R, and R will be connected to T. So if you think about it, it's just a data structure which holds all the characters. So all the top level node could be essentially 26 nodes, right? So let me just code it out, and maybe that it would be much easier for you to think about it then. So let's just say we are creating another trie node, and this is a class. So in that class I'll be making trie node star, and then I'll just name them children, and then 26 children, right? So there will be, so trie node is essentially a bunch of 26 nodes which are top level nodes, and then from that node, since you can see this class is calling itself, that means a node is connected to a node, and there on the top level there will be 26 nodes, and then you can, depending on what character comes right after one particular character in a word, you can essentially build the trie from there. So let me just create this, and another essential part of trie is that how would you know if the word ended at S, E, R, or T? Like you also need to keep track if how long is the word and at what point the word ends. So in this case, if we are building a trie on insert, it's going to be INSERT, and then after T we need to also make sure that after T that the information is stored that after T there isn't any character. So that's the end of the word. So for that we'll just use a boolean over here, which we'll call is word, right? So which will keep track of word. And then for the constructor, I'm gonna create, and then okay, so we just have a top level trie node has 26 children, right? But we also need to make sure that we initialize them with null pointers, right? So that way we'll know if we are traversing, if we encounter at any level a null character or null pointer, that means that there isn't any word connected to it. So I'm just gonna iterate let's say child and children, and then I'm just gonna make that child as null, right? And then at the end I also want to make sure that all that top level nodes has this is word equals to true, or is word equals to false, right? Initially we want it to be false. And then over here we will just initialize the top level node, which will be trie node root, and then constructor of that we're just gonna say root equals to new trie node. So we initialize that over here. And then in this particular question we want to implement trie, right? So there will be there are essentially three functions which we need to code. The first one being insert. So we need to insert whatever the word is into the trie, and then another API would be search. So within that trie, for example, if we look over here, so it initialized trie and then it inserted apple in it. and then after inserting apple, it calls the API of search on apple, and if you see over here, it returns true, right? Then we also do search on app. So there are these two APIs differ in a way that in search we want to search the entire word if the entirety of that word exists in try, and with search with, it just uses the prefix, right? So for example, if we do search with on app, it returns true just because if you see app is a prefix of apple, right? So start with, essentially we need to find if whatever words we have, if there are any prefix of that word which exists in try. So that's essentially that's why it returns true, and then it inserts app, and then it search app. Now it returns true because app and apple are now they are two different words, but they will share the same try because app is prefix of apple, right? So let's write down how to insert. So okay, since we are keeping track of top level try through this node, so we need to capture that first. So I'm just gonna say try node node equals to root, and then we are gonna traverse the word. So let's just say what is C in the word. So instead of doing traversing the word, I'm just gonna traverse the reference of the word, and then after that we will we need to store, since we it's a like a top level node has 26 children, so in order for us to keep track, instead of character, we are gonna just use the ASCII value of it. So I'm just gonna store it as key equals to, I just make it short to I equals to C minus A, so that will give me the ASCII value, and then I'm gonna check if node children of that I, if it's not there, so exclamation mark is essentially negating. If it's not there, then I'm just gonna create a new node. So node children I equals to new try node. So we have created that try node on that on the node of the children, right? So we need to create a new node, and then after that we need to increase the node pointer. So children of I. Okay, and at the very end of the word, we also need to make sure that we mark it as end of the word. So is word equals to true, so it marks that equals true. So what it does is it goes through all the characters. If there isn't any character in there, we'll just create a new node, and then we will increment the node so that it goes to the next character. And then at the very end, once we are done with inserting the word, we'll just set the node is word to true, because we're gonna mark that we already have a word now. And now, so if you think about it, in order for us to use search, it's essentially what it's gonna do. Search is gonna search the entirety of the word, but with prefix, what we can do is we can use the same search functionality, but we can stop earlier, right? So let me just show you how. Let's just encode, or let's just code the search functionality. So we're gonna do the same thing. We're gonna capture the top level node or root, and then we're going to traverse the word, and then store the ASCII value, which is gonna be C A, and then same thing. We are just gonna check if node children of I, if it's not there, then we can return false, right? Because there is a mismatch. And just node will be node children I, if we already encountered the particular character. Now it's gonna be tricky because, okay, and then we can return at the very end node is word, right? If it's not a word, it will return false. If it's the word at the end, it will return true. Now if you think about it, this is gonna look for the entirety of word, right? For this we are gonna do the same thing, but at the very end we'll return if so we can add a boolean function. We can essentially use the same functionality but add a boolean function. So you can essentially call this function, right, search with prefix as the word, but we can add a boolean function. For example, let's just say if I just do true and then I modify this functionality and make it a default parameter. So let's just say bool prefix equals to false. So by default it will be false, and over at the very end we'll just, instead of looking for if the particular node is at the end, like if we have traversed the word and if it reaches the end it will return true, otherwise it will return false, but we don't really want, right? For start with, we just want to see if the prefix of this exists, so we can stop early. So we can add a condition over here. If prefix equals to true, then return true, right? Because we have reached the end of the word, we have traversed the word. If it hasn't given us false, that means we have successfully iterated the entirety of the prefix, and then if it's true, then just return true, right? Instead of checking if it's the end of the word or not. So yeah, that's pretty much implementing the try. So just give you a quick overview. We create a try node, essentially a tree, but this tree will have 26 children, and every children is essentially a character or an alphabet. And then we also store if that particular word is false or is the end of a word or not. So if it's a word, for example, over here insert, it will go from I to N to it will start inserting, and as it reaches the end of the word it will just make it true over here and insert. And simultaneously search is very easy, just iterate through, and at whichever point you think that we don't really have that children, just return false. And prefix is very simple, just do a early stop. If we have iterated towards all the word and we did not find any mismatch, just return true at that point. So let's run this. Oh, okay, yeah, so I need to make this public in order for the other class to access it. So let's make it public, run it again. Something got wrong. Did I misspell it? Oh yeah, I forgot to add a D in here. Why does it say that? Okay, I think I know what's going wrong. I think I need to put a reference and then make it a null pointer. Let's see. Okay, yeah, it did submit, and let's just submit the code. So yeah, instead of you iterating in nodes, make sure that you're grabbing the reference of it so that you are properly assigning null pointer to all the child. Okay, let me just give you a brief overview. We implemented a new class, which is a try node, which will keep track of each node in the try, and we need to initialize. That's an important point. In constructor, we need to make sure that we are putting the values to false. And then insert is going to be easy, just iterate in that word, find keep the ASCII or keep track of the particular character. Over here I'm using XKey value to track it, and then if it's not there, then create a node, and then just traverse a node, go to the next one, and then mark it as true, because that will tell you that this is the end of the word once you are done with iterating through the word. Search is similar, just iterate in the word, do the same thing over here. Whichever there is a mismatch, just return false. If not, then traverse, and at the end just check. So we added this new parameter in search functionality. By default it's going to be false, but we added this parameter so that we don't really have to copy this code and just change this one little thing. We're just going to copy the same functionality, but this time we are just going to do true. If it's a true, then do a early exit. And that's pretty much the implementation of trie. It's very useful, so make sure you understand it properly, and I'll see you in the next video. Bye bye. Thank you.